Alright, so we've gone through quite a bit tonight. We still have a bit more to go, though, so classes. So what is a class? So a class is kind of like a function, except it is something that contains both data and other functions. So a class is essentially a collection of data and functions that are related to each other in some way. The best way to think of a class is like, say you have a player object or something you're working with in a game. Well, you would make that a class, the player class, and the player class has a couple things, right? It has some health, it has a name, maybe it has some armor, it has a weapon. It has some things it can do, like attacking, walking, taking damage, maybe some functions to determine if it has 0 HP, to see if it's dead. And then those would be your functions. So things that it does, or things that it needs to communicate to other parts of your game or other classes, those need to be functions. And things that it stores about itself are the properties of the class. Defining a class is different between whatever kinds of different types of JavaScript you're using. In this case, we're just going to call it a class. In RPG Maker, it's defined a little bit differently, and we'll talk about that in the next video. But so you just have a class, and then you have a class name, let's say player, and then you enclose, you do curly braces to enclose that. So again, we're going to go over to our handy-dandy stuff over here. So we have our class player. Like I said, we need some properties to store information, so these are going to be vars, because we need to use them throughout this class. We're also going to define them as private variables, because of something we'll talk about later called encapsulation. So var HP is there, or where do these go? How do we do this again? I looked this up once and I've forgotten how it goes, because it's something I didn't know that was possible until recently. JS private. Okay, it is just that. Okay. What's interesting is that JS Fiddle doesn't like it, though. Okay, so this is a private variable, which means it cannot be accessed from outside of this class, which is what we want. We want to have it be only accessible to the class. So HP name. That might actually just be there from some errors from before. We're going to say weapon. And we're going to have another one called armor. And then we're going to have some functions. So, function get name. I think we do that to get. Oh, we need to still use the thing, okay. So this is called a getter function. You're getting data to return to something that needs it. Usually when I do getter functions, I do them like this so that they are in one line, because it's really all you really need for these. Okay. So there's our getter functions. Then we're going to create a function called is dead, and this is going to return if this dot HP is less than or equal to 0. Function take damage. This one we're going to pass through a value, so damage. And we're going to say this, well, we'll actually make this a little bit, I'll make this an extra line here just so it can be more readable. So we're going to do what's called a ternary. So ternary is sort of an inline if statement. It allows you to define what happens if you get a true or false, and it takes a condition, but you don't have to write the whole if statement out. So this is how it kind of goes. So we're going to say this dot HP equals this dot HP is greater than 0, or this HP minus damage is greater than 0, question mark. So if this is true, so if HP minus the damage is still larger than 0, then we take this dot HP minus the damage. Or we do 0. If it will exceed, if it's so much damage that we're going to go down below 0 health, then we will just set to 0 and be done with it. And that's a ternary there. Very handy and very powerful little tool there. What else do we need? So we're going to have a move function that we're not really going to work with. So we'll just we'll leave it as this. We'll declare it, but we're not gonna actually implement the function. I think that's what we'll stop with that there. It's pretty good. So we have our class, player class here. We have some properties: HP, name, weapon, armor. These are private to the class, so we can't access them directly. So if I say let's player 1 equal new player, and I try and go player 1 dot HP equals 10, we're gonna get an error from that, I think. Access function, get name. Interesting. I think it's throwing errors from this. Let me just do a real quick search here. Okay. Yeah, that's kind of what we're doing. Do we need to have the... And this says, identify get name. Do these have to be defined? Something's kind of a little wacky here. Oh, they shouldn't have a function on. Okay, so these don't have function definitions. That's what it is. Okay, never mind. That's the part I forgot about. In other languages, you still use function when defining a function inside of a class, but not in JavaScript. So you can actually give them a default thing if you want to. And actually, we do need to make a constructor, I guess. We're not going to pass anything. We'll pass through name, but everything else will be just defined by default values. We'll give it. We'll do a random amount of HP. So we're gonna say math dot random times 100. So math dot random is a built-in library in JavaScript that has a bunch of math stuff in it. So this is gonna let us get a random value for the HP. Weapon. is going to be an object, and it's going to have damage 10, so the weapon does 10 damage. This.armor. Another thing, we're going to have defense 5. And if you noticed that we've already made a mistake in this code, yes, I do know about it, and that's intentional. So we're going to go through what the problem is. Okay, so first of all, let's go ahead and run this. Throw in the player, we'll call this called JoJo. Yes, this is the JoJo's reference. So go ahead and run this, and as you can see, we get nothing because, oh, let's do console.log player 1 dot. Interesting. This shouldn't be accessible. Like if I do car dot full name equals test, like this shouldn't work, right? Interesting. So how do you prevent people? Let's see. Let's actually look this up. JS private class member can still be initialized outside of the class. I would say prevent leave the start undefined if you don't want to. This is for Python. Let's see, is there actually something Java? Why is there not JavaScript in there? Can I prevent access to .property? This .property. Oops, constructor. Real private properties finally added in ES 2022. 2023 private property fields. So actually, okay, it might not be. I don't think this is going to actually. Yeah, this probably won't work in RPG Maker because this is something that's way outside of the time frame of when the code base that RPG Maker runs on, the JavaScript version it runs on, is. So this is something that's not really in RPG Maker, but it's still important to know because it kind of highlights, or should highlight. But nobody's actually stating, you know, if you set the value, right? I guess it's because we're not using the hash on there. I mean, I think that's stupid though. I mean, the property, it's a hashed, you know, it's a private property in the class, so just not using it in the instance that we're doing here shouldn't cause it to set this. Like not doing this, unless, I guess technically what we're doing is we're assigning a new property called HP to the class and then setting the value, is what I guess what we're doing. Yeah, so here we can't do this because it's a private field, yeah. So how do you prevent adding, here's a question then. Prevent adding new properties to a That's for a property, not necessarily a class. I don't know if you really can do that. May not be. It might just be part of the language you can do that. But yeah, so if you actually access it with the way you're supposed to, I guess, with this, which I think it should be either way, because this shouldn't be part of the name. This should be like a, essentially like it should be like, you know, var or let, right? It's like a identifier or a piece of the configuration of the property, not part of the property's name itself. But I guess they don't have it designed that way, which is kind of stupid. Yeah, so now when we do this, it's uncaught because we can't modify it. The only way we can get it at this point then is to do, and if we do this, we'll have undefined because it's not set. And if we do this, it should throw an error. Yep, and so we have to use the getter, which is get HP. Yeah, we get some random. Let's get to do it real quick here and do this. Math.floor. I'll get rid of the extra decimal places. Yeah. So we now have it. We have created this JoJo character. If we do get name, JoJo is the name. So let's say that we do something that does damage, and we're going to we'll do like a random amount of damage. Let's say let damage equal math.floor math.random times 25, and then we're going to say player 1 dot take damage, then we're going to say player 1 dot get HP. Run this. Whoops, what do we have? Isolate token, because we have too many. So, we didn't print out the health before either, so let's actually go and do that too. So we can actually see the damage happening. Alright, so 55, and we're taking, it looks like 22 damage from that one. So this is fine and all. So we're like looking through the code and say, okay, we took 22 damage. So we're looking at this, and we look at, well, wait a second, we have this armor that says defense 5. If we're taking 22 damage, well, let's also print out what the damage is, so we know what we're dealing with. So, whoops, there we go. So we have 43 health, we take 10 damage, and now we're at 33. But wait a second, we have this armor that we have equipped. How come that's not doing anything? Well, we're going to look at our take damage function and realize, oh wait, we didn't account for the armor in here. So what we need to do is we have to take the damage and modify it with the armor. So let damage equal minus equal armor. So we can use a minus equal or a plus equal or even a asterisk equal and slash equal with this. And so what this does essentially is you essentially take what you got over here on the right, and you're dividing it by the value of the variable, or you're multiplying it, or you're adding it, or you're subtracting it. In this case, we want to subtract it. And then when we do that, we also want to make sure that it's above negative if it is negative. So if armor happens to be higher than damage, we're going to make it become negative, and that'll be a problem. So one thing we'll need to do is say if damage equals, if damage is less than 0, then we'll say -1 times damage, otherwise damage. That'll flip it back to positive, so we'll have positive damage. And then we'll do the damage down there. So now when we do this, we should see that whatever damage we take 5 less damage. Whoops. What did we do? Armor. Oh, yeah. This dot armor. So, okay. Something happened there. So we have 51, we take 19 damage, so... Oh, this armor.defense. Stupid. There we go. So we have 6 health. We took 9 damage. In most cases that would kill us, but since we have 5 armor, that reduces it down to 4, and so we only take 4 damage. And we have 2. Now what we're going to do is we're going to increase this to 50. And we're going to do another console log here. Console.log is plus and then we're going to say this, or say player 1 dot is dead. If true, yes. And if no, okay. So, this is another ternary here, so what's going to happen is we're going to print this out, and then we have a ternary on if the player is dead, on the player's dead function. If that returns true, it'll show this message. If not, it'll show this one. So let's go ahead and run this. And as you can see, now we have 0, and is Jojo dead? Yes, bring on the new generation. So that is how a class works. With how a class should work. Let's put it that way. And the reason a class should work this way is because of encapsulation. Now, I run into all kinds of people on Twitter who have interesting opinions that object-oriented programming is something that should not exist. The answer is yes, it should exist. Not that it should replace what's called functional programming. So, functional programming is like this. Like, you have some stuff, you're doing some processes, and you're calling functions. You don't really have any classes you're working with. The data is all just kind of processed in one go. One file, one go. Object-oriented programming is when you have objects that store data, and then you essentially run an application by interacting with those objects. Most applications that run well are a mixture of both functional and object-oriented. So, the process that we used to go through and hide these things, right? I'm going to deal with all these weird spacing, indentation stuff. There we go. So, the process by which we're like hiding these, this is called encapsulation. So encapsulation is when you take stuff that belongs to an object and you hide it from stuff that is not that object. So if we create like then we created this player object and then we were trying to access the HP directly and it was saying you can't do that, that's encapsulation. Essentially, encapsulation is any kind of property that belongs to an object should only be viewable by that object. And if you want to see what the value of that value or that property of the object is, you have to ask the object to tell you. In other words, you have to call a getter function to return the value to you. You can't just go into their house and knock their door down, wreck all their crap, and pull the value out pull the value out at gunpoint or something like that. You have to ask the thing if you can get it, and then it will return it to you. If it wants to return it to you. So if it's programmed, if you have a function to do that, it will give it to you. And this is so that things can't modify data and change it when it shouldn't be. It's a way to essentially protect the data that belongs to an object, so outside interference can't happen, and you can't have people putting in random values and causing things to happen that shouldn't happen. So that's what encapsulation is. I'm actually going to say put this up here. So we're not going to redo that. So classes and encapsulation, and then we'll just put a note down here. Encapsulation is when objects properties are protected from being viewed from. Actually, we're going to create a comment block, which you define by doing this. A slash and an asterisk, and then you close it by doing the opposite. Asterisk and slash. Okay. So, inheritance. Yeah, this is going to be a necessarily long video because we're talking about some pretty intense stuff here. Now, so inheritance is another part of object-oriented programming and something you're going to see a lot of in RPG Maker. Encapsulation, kind of, but not so much. Encapsulation, there's really no encapsulation in RPG Maker for the most part. But when it comes to inheritance, it's all over the place. So inheritance is kind of what it sounds like. You have a class that inherits things, properties and things from another class. So let's say that we have the player class that we have, and then we have so let's say we have this player class again. And let's say we have another class called enemy. And we have all the same stuff. All the same, pretty much all the same functions. And let's say that instead of, let's say take damage, and let's say that it can also do damage. So let's say the player doesn't do damage for some reason. Let's say this is a game where you're essentially just looking for things and you don't do damage, like maybe Fatal Frame or something. So only enemies can do damage. So do damage. Or I'll say get damage. And that's going to return this dot. We're going to say math.random, math.for. Math. Alright, so what's going to do is we're going to get a random value out of 60. We're going to add the weapon damage to that and return that as the damage. So at this point now we have these two classes that have all this code that's in common, and then they have this one thing that's not. So what we can do is to refactor this, which is to reduce. Refactoring is reducing the code that you have if you have repeated code. What we can do with this is we can say that is there. Let me see. Let's check one thing. JS. Let's see. Protecting. Underscore, okay. So this is good to know. So they do have this. Good. So let me see. So if value is less than 0, 0, okay, that's fine. Then we have a setter and then a getter. Let's say we have this, right? And we want to create a class that will essentially contain all the code that's the same between these two classes, but then also allow these classes to access that code, so that we don't have them having to repeat it. And then they'll have the enemy class will have its specific do damage or get damage function defined there for itself. So the way that this works is we have to create what's called a parent class. I have to say parent and child because that makes sense in terms of inheritance. That's like a really easy way to describe it. A lot of people, when you ask them about it, will talk about super and subclasses. Technically, that's the correct terminology, but you can't understand that if you're not familiar with what the topic is. If you say inheritance and you say parent and child, people say, "Oh, the parents and the child's inheriting stuff from the parent." Kind of like how genetics works. This is kind of like genetics, but for programming. So what we're going to do is we're going to make a class. We're going to call it entity. And we're just basically going to copy up all this stuff into there. Because everything that's in the player class is what's in the enemy class. The enemy class is the only thing that has something different, so we want to put it all into here. And we're changing all this to underscores. So what an underscore does, it makes it protected, which means that I believe, I actually didn't check what that actually means. Yeah, okay, that's exactly what it is. So, when you're dealing with inheritance and dealing with encapsularity or encapsulation with inheritance, the main problem is you can't use privates, right? These cannot be private properties. That's because if these are private, you can't access them from the classes that inherit from this class. Even though they inherit stuff, private properties, they don't get inherited. Don't get inherited and moved like that. So what protect does is it protects the properties from outside interference like you do when they're private, but it allows them to be passed down and accessed by anything that extends the parent class. An extend is just another term to say that it's inheriting the stuff from it. So we need to go through and change all these from what they are to the underscores, because that's what you use to define a protected property in JavaScript. Not to be confused with Lodash, which is a different type. So this is a property, right? And this is a Lodash property. That and like say some function name here. This is like as I use Lodash, which is a type of JavaScript. So that can get very confusing, I think, if you're not careful. Yeah, you have Lodash, you have Node.js, there's technically React and Angular types of JavaScript as well. There's nw.js, which is technically a kind of web-based Node.js. You got Pixie, there's all kinds of different jQueries, all kinds of different libraries for JavaScript that do different things and allow you to do different kind of formulations of stuff. Code. So we have all these things now that are set up in the correct way. So now what we're going to say is that player class, we're going to say, I think it's extends, right? This is the keyword. Yeah. Extends, and we're going to say entity. So like I said, player is not going to have anything specific about it because we aren't going to put anything new in there. But enemy is going to have its get damage class. So we're going to leave that particular function here, removing everything else because it will inherit all that stuff from the parent. We'll just change this to underscore weapon damage. Extends entity. And now what we can do is we go ahead and say let's mob equal new enemy, and we say name, say slime, We'll say let's player equal new player, player 1. There's no name conflict there. Player 1 equals new player, Jojo. Still use Jojo there. And that's throwing an error because we already have player 1 defined above, but we're going to throw this into GS Fiddle now. And then what we're going to do is we're going to get the damage by using mobs. So we're going to say let damage equal mob.get damage. And then we're going to go to player 1. I'm going to say take damage. Damage. And then we're going to do that same other thing we did for the other one. So we grab the console out. Nope, so we're still alive. Let's also add in the other ones as well, so we know what we're getting ourselves into in terms of damage. So you can see we're kind of doing a flat 10 damage. Which is interesting. So math.random divided by 60 plus this underscore weapon damage. Oh, because it should be times. Done. There we go. So yeah, and there you have. This is pretty much your example of class inheritance. So we have a class entity that has all the common properties that are protected from access from the outside. We have two classes that extend the entity class called player and enemy. Player is basically just a carbon copy of entity for now. Enemy has a specific property called get damage. That returns about an amount of damage that it does using the weapon in this other random calculation. Now, if you wanted to, we could also extend. We could actually override a function, which means we redefine the function and change what it does. So, like if I wanted to say on take damage, let's say we want to change it for player. So we're going to add take damage back into the player, and we're going to say defense armor defense times 2. So we're gonna double the defense that armor gives, and what'll happen now is instead of using this take damage, it's going to use the take damage that's defined in the player class because we're going to override what's in the extended class. So now we should have less times where Jojo is dead. Well, maybe not because the calculation is spitting out pretty large amounts of damage. But there's more times when he's not dead. Let's also print the actual HP too before we do the damage output. So here we go with 31. We have 19, so we're taking 19 damage. And then what should be happening is we're taking off 10 because we're doubling our defense, right? So if you look at this and we take off 10 from this, that becomes 9. 9 minus 31 is 22. So yes, that is working. And this is how you can do overriding. Again, this isn't exactly how class inheritance works in RPG Maker, but it's the same general concept, which is why we're talking about it. All right, let me go ahead and save this into our file. So we have that for that example. And we're going to move on to the last topic, which is code readability and writing clean code. Okay, so clean and readable code. This is probably the most important topic outside of talking about objects. because this is going to affect the maintainability, the readability of your code, and the ability of other people to read your code and maintain it if you have other people work on your stuff that you write eventually at some point. So for those of you that do programming, I'm going to type out some variable names here, and maybe you'll recognize a couple of them, and I'm going to chastise you for them because there's no reason to write them this way. So the least offensive bad way to write a variable name would be something like char name equals character name. A worse way to do this is and then the next most egregious way to write this is this. And then you would have maybe the very worst version, which would just be like C. Okay. So these are all examples of bad ways to write a variable name, right? So this one's passable. You know, this one can slide sometimes. This one, never. There is no reason to remove those characters. You don't save any time by doing it. There's no reason to do it. You're removing a couple of characters that's going to add to maybe 1 byte worth of data. Don't do this. This is lazy coding. It's bad coding. If I see this in your code, I'm immediately going to say that your code has probably got other problems with it and start taking out the magnifying glass and looking for issues. If you have this, don't even bother. If you have this, I'll laugh at you. And the reason I'm saying I'm going to laugh at you with this is because, believe it or not, we have stuff like this in RPG Maker where you have a variable that's just 1 or 2 characters long that has no relation to what the data is. It's literally just, you know, SW, SD, SH, DX, DY. By looking at what they're doing with the data, you can kind of piece together what it is, but these are professional, hopefully, programmers creating a software that's being released for sale commercially, writing code like goddamn noobs. Not offense to any noobs, but we're talking about people that should know better, and people that are managing those people that should know better, and then people that are responsible for the direction of the project that should know better, that all said, yeah, that's fine. That's incompetence of the highest level. And frankly, the people that wrote the code for MV should be fired. If that sounds a bit harsh, it's harsh, and I agree, but it is the truth. The people that, not the developers, but the people that approved releasing the code with that kind of stuff in it should be fired, because they are not, they either are not responsible enough to be leading a project, or they don't have enough experience to realize that shouldn't be there. Either one of those two, there's no other possible reason why they would let that go. And the reason for that is because you look at this character, and this, you don't know what the data is, you just see, you see something like this, like, return C plus space plus a dot length. I have literally seen this before. Plus so, can you tell me what the hell this code does without knowing what the variables actually are storing, right? And here's a kicker for you. This doesn't necessarily have to be an array. Length is also a string property to get the length of a string. It also works on an integer too, and a float, I believe. There are multiple types of data that use .length, so this is not immediately an array. Now, it does say A, so you might be able to possibly assume at your own risk that this could be an array. I'm going to tell you now that it's not. So if you assumed it was an array, and again, the length of a number of elements, then you've read this wrong already. So what this is a so C is actually a class name. A is actually the attack power, and T is a array. And it's storing the number of hits. And what this is essentially doing is returning a concatenated string that's in a format that's going to be split apart later and then used to process the total attack power a class can do if it hits multiple times and display it somewhere. And see, this is exactly the problem. Like, you would never guess what the hell this is. I mean, maybe you could like follow along the execution of where this goes to and say, oh, this is what this is, but you shouldn't have to do that. You should know exactly what this is right when you see it. You see it return. Whatever it's returning should be written in a way that you know what it is. So the proper way of writing this would be class name, and then say like some class, and say like warrior. A is going to be the let's attack. What is, I wonder, I'm going to see what this does. Actually, I'm curious. Oh, actually, you can't use it on an integer. Well, la-di-da. Okay, it's undefined. So that wouldn't have worked anyway, but again, you wouldn't be able to tell why it's failing, because if you didn't know what the data type was. Well, I guess you could debug it and find out what the data type is, but so we're going to take that out. I'm just going to say 10, or attack power. And this is T, which is going to be let's number of attacks. So 2. Now you know exactly what this is, what it's doing. Yeah, class name, you're concatenating with attack power number of attacks into a formatted string. And then you can kind of follow this along and see what it's doing. So this is properly named stuff, and this is how it should be written. Now, something like this is fine because, you know, ATK in terms of gaming is almost always going to be attack. That's like a really common acronym for it. I'm fine with that. Stuff like this, where then you go like this, there's no reason to do this with power. There's absolutely no reason to remove those vowels. But I'm okay with like shortening this down a little bit. Still, this is the more proper way to do it. So if I see like the ATK, I'm not going to say anything. This is just the better way to do it. If I see like stuff like this, calling you out, putting you on blast, full blast. So creating readable code means giving variable names that have meanings and that describe what the data is properly. Now, the same thing applies to function names. If you have a function that, just like what we did up here with like the print data function, it's just printing out data. But the longer this function becomes and the more things it does, the more complex the name has to be. So like if we pass in data, it's doing this, and then we do something else on top of that, it's got to say format data and format and print data. Let's say it's like getting all the data into a list, taking that list and like doing something with that data, like it's creating all the strings in the list are being modified. Then you're displaying them. Then the function has to be called something along the lines of modify and print data or something like that. Because it does two different things. It doesn't just printing data, it's doing some other actions that are not related to that. Ideally, what you would do is you create another function to process that data transformation, then pass in the change to data back into this function to print it out with this, or something similar to this, because it would just be a list at that point. But it's fine to put them both in the same one. You just have to make the name be representative of what the function actually does. And the longer the function is, the longer the more exact the name has to be. Same with property names, with variable names. the longer it is from when the variable was defined, the more complicated, the more exact the name has to be. So it has a meaning that retains through the entire process of where it's used. And you should also be defining variables just before they're used, not at the top of things. Like at the top of a class is fine, but like in a function, if you got like a pretty long function and you have like multiple things that are happening, you have multiple variables, don't define all the variables at the top. If they're not used in the first part of the function, define them where they're used at. Or just where around the area they're used at. If they're like inside of a for loop, you need to be outside of the for loop for scope reasons. Also, try to avoid, actually I shouldn't say try to avoid, never use vars inside of a function or an if statement. Only use vars when they're outside of your functions as part of your plugin and should be accessible by your plugin. Otherwise, you should be using let all the time, every time. There's no reason to be using var anywhere except outside of functions and outside of classes for that matter too. It's just var inside of a function is just going to get messy, especially when you're dealing with like different types of scopes, and if you need to have like a variable that goes from one scope to another and doesn't retain a value, gets redefined. If you're using a var, you're going to get an error for that, and seeing vars everywhere is a very clear indication. One is somebody that doesn't really know what they're doing, or two, a very old code when let didn't exist, or the use of let was not standardized, or not really standardized, or not encouraged, or wasn't really heavily pushed. So that brings us to the readable code section. So part of writing clean code is writing readable and meaningful names for functions and variables and classes and stuff. The other half of it, though, is that the code that you write and how it is processed should be readable. Like, you should be able to see, like, for example, like this, for example. This is a pretty complicated function, but for the most part, you can kind of see what's going on. Like, we're looping over, we have our data object, and we're getting the keys from the data object. We're looping over the keys. We're getting the data. We're looking to see what the constructor of that data is. If it's an array, we're doing some stuff. If it's an object, we're doing a recursive call. If it's neither of those, we're printing out the key as a label, and then we're displaying the data in the console. If I just said like k, we just had like object data. We have this say like od. Let's make this like L. Let's make it some random ass character. K is a little bit, because K is a little bit too understandable still. All right, so now looking at this function, can you tell what it does if we hadn't just described what it did earlier? So you have this thing you're passing in called od. We're doing a for in loop with L as the variable that's storing. At this point, L could be index, because this might be could be potentially an index in an array. This is still possible because you can store any type of data in an array, right? So you might look at this and say, well, this then is an index of a list because we are looping through it. So obviously we're looping through some kind of iterable object. We're using an in loop. We're checking the constructor of the data inside of the element for that list, and then if it's an array, we're passing this down, and then you see if object, and then you say, oh wait a second, we're passing an object in as a parameter. And then you have to go back and like reevaluate what this is and say, oh wait a second, this is actually object data, and this is a key. And then you see, oh okay, that's what this is. So if you're just looking at a function like this, until you reach a point where something is there that like describes what the function actually is, and you don't see where this is being called from, obviously, and what the data you're passing in is, and you see this line here, this is when you realize this is not an array, this is an object, and we're looping through keys. And this is an example of very poorly of code with bad readability. You don't know what it's doing. It's very easy to misconstrue what it's doing. And then at some point in this process, you look at something that's happening and realize, oh, wait a second. This isn't what it was. It's not doing what I thought it was. It's something entirely different. So this is an example of code that's poorly written, that should and would be thrown back to the developer by somebody reviewing it, like an enterprise situation. and you need to make sure that you're actually using things that mean what they mean and things that describe what's really going on. So, calling an object data and key and then using that all the way through is very important in making this readable. The other thing about readable code is never use comments. Now, you might have heard from 1,000 different people if you're just starting programming and having like reading comments and going on Stack Overflow and reading books and stuff. You might have seen from 1,000 people, oh, you got to make sure you put comments in your code. Those people are not serious people. It's end of discussion, really. Not serious programmers. Even if they're like been in the industry for a very long time, they're very famous and have all kinds of books. I'm gonna say don't listen to them, but take what they say with a grain of salt, because the reason you would put comments into code, and if they say like comment your code heavily, the only reason you would do that is to tell people what the code does. Now, here's the problem. If your code doesn't say what your code does, and you can't write your code in a way that explains what the code does, how are your comments that are using to explain what the code does going to explain what your code does? Again, stay with me here. If you can't write your code in a way that just explains what it does, it can't be done. You can't do it. So if you can't write code that is readable, that has clear naming conventions, that has consistent naming conventions with variables and stuff that have names that describe what the data is and how it's being used, how can we expect you to write comments that describe that as well? Now, there are some caveats to that. If you have some really super crazy complicated code that's doing some very specific things, at that point, write a couple comments. That's fine. If you want to describe what a function is doing, fine. You can do that. But if you're going into every single line and like saying this is what this is doing, this is what this is doing, this is being used for this, it's changing this data to this, we're then taking this and adding it to that, so we get this type of value, and then we're taking this value and returning it so that this other part of code can be used. And then we go to the other part of the code, we have more comments about how this value isn't taken and done. This is done with that and that and that. So, one, those kind of comments are not useful. Two, 9 times out of 10, you don't need to put them in, and they're a very strong indicator of code that is code that's probably written incorrectly, and definitely of code that somebody that doesn't know how to write clean code. The other part of it is that as you are maintaining that code over time, you run into situations where your code gets modified by people and they don't update the comments because they're like, well, whatever, these comments are here, still kind of does the same thing. We just changed a few things, add some stuff in, still relatively the same. I'm not going to change the comments. Now the comments you wrote to tell you what the code does don't actually tell you what the code does anymore. So your code is no longer readable, it is still not readable, and your comments no longer tell people what the code actually does. So nobody knows what your code does. And depending on how badly it's written, it may take a while for somebody to kind of piece together and say, okay, this is what this is all doing. Like we were doing with this one up here, right? When we rewrote this function to be all jacked up. We didn't really know what was going on until we got to this line and realized, oh, we're passing through an object to this. This is a recursive function. And so this is actually an object that we're passing through. And this is a loop over the keys of an object, and all this stuff is actually accessing object properties. Until we saw this line, we didn't really know what the hell was going on with this. We correctly assumed that this was just a list of indices being looped through, and we're pulling out the values of the array with those. So, and if those comments were in there, and then that function was changed at all, those comments no longer make any sense because they don't describe what the function does now. Because 10 times out of 10, nobody updates the comments. If you find somebody that updates comments when they change code, give them a frickin' award or something, because nobody does it. Pretty much nobody. 9.89999 times out of 10. Code does not changing the code does not mean means that they don't change the comments if there's comments about the code. So again, try not to use any comments. Try to write code that is readable. If you have any situations where you want to comment out code using like comments like that or this to essentially prevent code from running if you're not sure if you need it anymore, or if you're testing other things you don't want that to run. If at some point you realize you don't need that code anymore, just delete it. Instead of leaving it there, just you know, you don't want to see this in your code anywhere. You don't want to see this in your code anywhere. Believe it or not, I have seen like thousands of lines of code commented out in production code in an enterprise solutions that has been there for 20 years, and everybody's been afraid to delete it because they think that, well, it was commented out and not removed for a reason. We might need it later on or something, I guess. We'll just leave it in. And that's just, the reasoning just keeps on getting passed down and passed down and passed down between developers that come and leave the team, and it just never goes away and stays in the file and bloats it up. So, if you see code commented out and you don't immediately know that you don't immediately come to the conclusion you can use it, just delete it. If you're using version control and you realize you have to keep it later on, you realize later on that you needed it actually, you can just go back and find the commit where you removed it from and copy it back into your code from that commit, from your GitHub repository. Simple as that. There's no reason to leave code commented out unless it's actually something you commented out temporarily. If you don't need it, delete it. That will also help keep your code a little bit cleaner too. The other thing is making sure that things are organized correctly. So if you have like a bunch of getter functions, keep those together. If you have setter functions that allow you to set a value from an external source, put those together. Everything else is just kind of a helper function or does something else. Put them in their own section and put a comment to like describe what the section is. That way things get grouped together and they're easier to find that way. Same thing with variables. If you have a specific group of variables that are for one thing, keep them together. If you have variables that are for something else, don't put them with those. This helps keep things clean and easy to manage and find and look through and read. So that's pretty much all I have, really. So what I'm going to do is after this goes up, I will, well, before this video goes up, I'm going to push this up to the repo. I'll put the repo link in the description below if you want to go and look at it and download this code and mess around with it in like JS Fiddle or something. And then, yeah, we will reconvene in episode 4. The plugin of hope. But yeah, we're going to be making a plugin for the next episode. We're going to be making a very simple plugin. It's going to be called the Dialog Selector plugin. And essentially what we're just going to do is we're just going to create a means for an NPC to pull in dialog from the plugin. So we're going to give going to create a plugin setting that has dialog text in it, and then the NPC will pull from that to display it. Very simple, pretty easy. Just kind of getting our feet wet. Explain how plugins are structured, how to make them, how to make simple ones. All we're going to do with this is just create a plugin setting. We're going to pass that into the plugin. We're going to format it. We're going to set up a game variable to store the message that we're on. And then we're going to use that to then just loop through it and pull the dialog out for the NPC. And the reason it's going to be simple like that is because we're going to make it more complex over the next 2 or 3 videos after that to make it a more comprehensive system. And eventually what we're going to have is a dialog tree system where selecting different options and text and things will cause other NPCs to have different dialogue that they say, all without having to use switches or game variables or anything like that. It'll just run directly from one page of an event, and we'll call a plugin command to run the dialog for it, or at least to get the text into maybe a variable, and then we'll use that variable in the text window to display the text, and that still will just run in one page, and will allow you to process your dialog with not having to have much eventing to make that happen. Now, it's obviously not really there's no practical use for this plugin, but it's a good way to just kind of ease us into some more of the complicated stuff. Because this plugin, these 3 plugins that we're going to be doing, that will make that more complex are not going to deal with anything except for just those areas and then more complexity to them before we jump into scenes and windows and things that get really complicated. Like dealing with plugin, large amounts of plugin data that's fairly complicated, core plugins and how those can be used to really make your plugins more efficient, and then doing some really complex plugins later on that deal with a lot more things. So I got lots of stuff planned, lots of interesting things that we're going to work on, and you notice this video is like 3 hours long. This is probably going to be the usual length of the videos going forward, like over an hour and a half, 2 hours, 2.5 hours. The next one probably won't be quite so long because it's pretty simple. We'll probably finish the plugin in about 45 minutes. Testing might be a little bit longer, so it could probably be like an hour and a half video, probably. Maybe a little bit longer because we'll kind of be describing all the stuff as we're making it and kind of going over everything in it, in the process of making it. After that, though, like each successive video will get longer and longer because it's going to be more complex and more complex. And we'll start getting into the point where I have videos that are probably recorded over multiple days. And at that point, I'm not sure like if I'm going to have a limit of time I want to have. Like once this gets edited down, it'll probably still be like about 3 hours, to be honest. But at that point, am I going to have like are we going to subdivide the videos into different parts, and I'm going to release all the parts on the same day, or am I going to use those every week or something, every other week? I think what it'll be is it'll be all the videos from one episode will be released at the same time, but I'm going to break them down into reasonable sections, maybe based on what the content in them. So like maybe the first part of like setting up a plugin and getting the idea down and all the stuff we need to have, like the development document, essentially, kind of process of it. Preparing to write the plugin, which is like setting up all the stuff we need to have for the project and getting the header for the plugin finished, and then actually writing the plugin. So maybe like how it might be broken into 3 different episodes, or it might just be broken down just by time. Really, I have no clue how I'm going to do it. The only thing that's wrong with breaking it down by time is it might be right in the middle of something. So I might break it down by. It makes sense to break it down by section, like the first example. The only problem with that is that it could be equally as long. So we'll see if we can figure out what the hell we're gonna do with that. But it's gonna we'll have to do something, because I can't just put up like a 10-hour long video and expect people to watch it. One thing that'll help, though, because one thing that we did while we're explaining everything in this, that's why it was so long, the videos after this, once we get to a certain point, I'm going to be like speeding up sections. Like if I'm just doing a lot of just coding and not really talking about specific things. Like once we get to like the 5th or 6th plugin we're working on, I'm going to stop like explaining everything and just start coding things, and then explain what I coded generally after the fact, and not going through every step. Because at that point you should be able to follow along reading the code as I'm kind of going through it after I've written it, and those sections will be sped up, so that'll also help a bit. But it's still going to take a long time to do some of these later plugins. Like one of the last couple ones I have planned are one for implementing chart.js in RPG Maker. We're going to have one where we're going to actually build out a plugin I have planned that I'm making. It's essentially like going to be a Legend of Dragoon inspired random encounter meter. Where you're going to have something hovering over your head, and it's going to change colors depending on how close you are to running into an encounter. And we'll probably do a mini version of my Codex plugin, just to kind of show you how you can use JSON to create a really customizable plugin. I say mini version because the Codex plugin I have is freaking massive. It's like 10,000 lines of code, and it's taken me like literally 2 years to finish. So I'm not going to do that on stream, on this, something like that, of that caliber on this tutorial series. That's a little bit too much. But that's the kind of level of stuff we're going to have towards the end of this. Just going to give you an idea. But yeah, so thanks for watching. Comments, questions, leave them below. If I came after you a little bit too hard on the readability stuff, let me know. and I will laugh at you. No, I won't laugh at you. But so let me know what your thoughts about all that are, because it's something that I've like really started looking into lately, and mainly because I used to be one of those bad, unreadable code writers, and some of those habits that I had in the past still are with me, and I get my ass chewed out occasionally at work because of it. So I've been trying to really kind of hammer in that can't do that crap anymore, and making sure that people, when they're just starting out, think about these things before they start, so they don't develop those habits. Is kind of something that I want to make sure happens, because writing good, clean code is going to not only help you write plugins that are understandable and you can modify over time, but also if you ever decide to go into coding as a career, being able to write clean code is kind of essential in that case. So this is also a series that can help train you with an actual usable skill that you can use for a career, or if you want to start like a side thing where you're developing like websites or something for people, that too, make money from it. But yeah, so I'll catch you guys in the next video, and we're going to go into making that plugin. But until then, this is LMP Games, and I will catch you guys later.